Listening Practice, Chapter 1, Introduction to Technical English 1.1 The importance of English in engineering, global collaboration. English is the lingua franca of engineering, enabling communication in multinational teams, e.g., engineers in Germany collaborating with manufacturers in China. Case study: the Airbus A380 project involved engineers from 15+ countries, relying on English for design specifications and safety protocols. Access to resources: 80% of technical journals, patents, and standards, e.g., ISO, ANSI, are published in English. Example: understanding IEEE papers or software documentation, e.g., Python libraries, requires proficiency in technical English. Career advancement: employers prioritize engineers who can write reports, present ideas, and negotiate contracts in English. Survey insight: LinkedIn data shows engineers with strong English skills earn 20–30% more in global roles. 1.2 Differences between general and technical English. Aspect: general English, technical English vocabulary, everyday words, e.g., run, make, discipline-specific terms, e.g., torque, algorithm, grammar, active voice, varied sentence structures, passive voice dominates, e.g., the circuit was tested. Purpose: express emotions, tell stories, convey data, instructions, and analysis clearly and concisely. Tone: informal or literary, objective, precise, and devoid of ambiguity. Examples: social media posts, novels, technical manuals, research papers, CAD notes. Key differences in practice: general, the machine works well. Technical, the CNC machine achieves a tolerance of plus or minus 0.005 mm under standard operating conditions. 1.3 Key skills for effective engineering communication. 1. Clarity and precision, avoid vague terms, e.g., fast completes in 2.3 seconds. Use diagrams, charts, and equations to supplement text. 2. Active listening, decode accents and technical jargon during meetings, e.g., CFD analysis in aerodynamics. 3. Cultural sensitivity, adapt communication styles for global teams, e.g., indirect versus direct feedback in Asian versus Western cultures. 4. Technical writing, master formats like lab reports, proposals, and SOPs, standard operating procedures. 5. Presentation skills, structure talks logically, problem methodology, results, conclusion. 6. Critical reading, extract key data from dense texts, e.g., identifying tolerances in a mechanical drawing spec. Chapter takeaways: English is non-negotiable for global engineering roles, from interpreting schematics to presenting innovations. Technical English prioritizes precision over creativity, using discipline-specific terms and passive voice. Effective communication combines language skills with technical knowledge and cultural awareness. Next chapter, Chapter 2, Core Engineering Vocabulary, dives into mechanical, electrical, and software engineering terminology. Practical exercise: rewrite a casual email, "We need to fix the machine soon," in technical English, specifying the issue, proposed solution, and timeline. Compare a paragraph from a general news article with an engineering journal to spot differences in tone and structure. This chapter lays the groundwork for engineers to bridge language gaps and excel in technical collaboration. Chapter 2, Core Engineering Vocabulary 2.1 Mechanical engineering terminology, torque, rotational force, e.g., the engine produces 300 Nm of torque. Stress versus strain, stress, force per unit area, MPa or Psi. Strain, deformation under stress, dimensionless ratio. Thermodynamics, key terms like enthalpy, total heat content, and entropy, disorder in a system. CAD, computer-aided design software tools like SolidWorks or AutoCAD for 3D modeling. Fatigue failure, material breakdown under cyclic loading, e.g., airplane wings. Example: the crankshaft's fatigue resistance was tested under 10 cycles at 200 MPa stress. 2.2 Electrical and electronic engineering terms, voltage, V electric potential difference, e.g., 1-2V battery, current, I flow of electrons, measured in amperes. Ohm's law, V equals IR voltage equals current times resistance. PCB, printed circuit board base for mounting components like resistors and ICs. Semiconductors, materials, e.g., silicon, used in diodes and transistors. Case study, designing a solar inverter involves calculating efficiency, /eta equals /frac p _ text out p _ text in times 100 %, and managing harmonic distortion. 2.3 Civil and Structural Engineering Lexicon, load bearing, structural elements, e.g., beams, columns, supporting weight. Modulus of elasticity, /e material stiffness, e.g., steel, 200 GPa, reinforced concrete, composite material with steel rebars for tensile strength. Geotechnical engineering, terms like bearing capacity, soils load support limit. ASCE 7, U.S. standard for minimum design loads in buildings. Example, the bridge's pier was designed for a live load of 50 kN/m superscript 2 and a safety factor of 2.5. 2.4 Software and computer engineering jargon, agile, iterative development method, e.g., Scrum sprints. API, application programming interface rules for software interaction, e.g., REST APIs, debugging, identifying and fixing code errors. IDE, integrated development environment tools like Visual Studio or PyCharm. Machine learning, algorithms, e.g., neural networks, for pattern recognition. Case study, a cloud migration project required optimizing latency, response time, and ensuring scalability, handling 10,000 plus users. 2.5 Cross-disciplinary vocabulary, sustainability, terms, life cycle assessment, LCA, carbon footprint, circular economy. Example, the LCA revealed a 30% reduction in embodied carbon using recycled steel. IoT, Internet of Things network devices, e.g., smart sensors in HVAC systems, AI, artificial intelligence applications in predictive maintenance and robotics. BIM, Building Information Modeling 3D modeling for architecture, engineering, and construction. Example, IoT-enabled vibration sensors in the factory detected bearing wear, triggering predictive maintenance. Chapter takeaways, discipline-specific terms, precision is critical, e.g., stress is not equal to strain, voltage is not equal to current. Cross-disciplinary relevance, concepts like sustainability and IoT bridge mechanical, civil, and software fields. Global standards, familiarity with terms like ASCE 7 or REST API ensures alignment. Indiana multinational projects. Practice exercise, 1. Write a paragraph describing a simple mechanical system, e.g., bicycle brakes, using terms like torque, load bearing, and fatigue resistance. 2. Convert the sentence "the software works with the hardware" into technical English using terms like API integration or embedded systems. Next chapter, Chapter 3, Grammar Essentials for Clarity and Precision * covers passive voice, concise writing, and avoiding common errors. This chapter equips engineers with the vocabulary to communicate technical concepts accurately across disciplines and global teams. Chapter 3, Grammar Essentials for Clarity and Precision 3.1 Passive voice in technical writing, purpose, emphasizes actions or results over the actor, common in lab reports, manuals, and research papers. When to use, when the performer is unknown, obvious, or irrelevant, e.g., the alloy was heated to 500 degrees C. To maintain objectivity in scientific writing. Avoid overuse, balance with active voice for clarity. Passive, the circuit was designed using CAD software. Active, We design the circuit using CAD software. Exercise, convert active sentences to passive in a lab report excerpt. 3.2 Concise sentence structures, eliminate redundancy. Wordy, it is observed that the tensile strength decreases under prolonged exposure. Concise, tensile strength decreases under prolonged exposure. Use bullets/lists, for specifications, steps, or components, e.g., asterisk requirements, 1 voltage, 1 2V, 2 tolerance, plus or minus 2%. Avoid nominalizations. Weak, the implementation of the algorithm was performed. Strong, the algorithm was implemented. Exercise, revise a verbose technical email to improve clarity. 3.3 Technical descriptions, tenses and modals. Tenses, past, methods and results, e.g., asterisk the prototype was tested under 10 knots load. Present, established facts or general truths, e.g., steel conducts electricity. Future, predictions or recommendations, e.g., the system will require maintenance annually. Modals, may/might, possibility, e.g., overvoltage may damage the sensor. Should, recommendations, e.g., safety protocols should be followed. Must, obligations, e.g., the device must comply with ISO standards. Exercise, rewrite ambiguous statements using appropriate modals, e.g., asterisk the valve opens, the valve may open under pressure. 3.4 Common grammar pitfalls. 1. Articles, a, and, the, use the for specific nouns, e.g., the prototype in section 2, omit articles for general concepts, e.g., efficiency is critical. 2. Prepositions, results of the test, possession, versus results from the test asterisk, source. 3. Subject-verb agreement, the data show a trend, plural, versus the dataset shows a trend, singular. 4. Dangling modifiers, incorrect, after calibrating the instrument, the measurements were recorded. Asterisk, correct, after calibrating the instrument, we recorded the measurements. Asterisk, exercise, identify and correct errors in a technical memo. Chapter takeaways, passive voice, prioritize for objectivity but avoid ambiguity. Conciseness, trim redundancy and use lists for readability. Tenses/modals, match verb forms to context, past actions, present facts, future recommendations. Grammar pitfalls, master articles, prepositions, and subject-verb agreement to enhance professionalism. Next chapter, Chapter 4, Reading technical texts focuses on strategies for manuals, research papers, and specifications. Practice activities. 1. Convert 5 active voice sentences from a project report into passive voice. 2. Revise a technical paragraph to eliminate nominalizations and redundancy. 3. Write a safety warning using modals, e.g., loose wires should be secured to prevent short circuits. This chapter ensures engineers communicate with grammatical precision, reducing misinterpretation in global collaborations. Chapter 4, Reading technical texts. 4.1 Strategies for scheming and scanning. Scheming, rapidly reading to grasp the main idea. When to use, previewing research papers, manuals, or reports. Techniques, focus on titles, headings, abstracts, and topic sentences. Ignore details, note keywords and recurring themes. Example, skim a journal abstract to decide if the paper is relevant to your project. Scanning, searching for specific information. When to use, locating data, e.g., voltage specs in a manual. Techniques, use headings, tables, and bullet points as signposts. Look for numbers, symbols, or bolded terms. Example, scan a technical data sheet to find a component's operating temperature range. Exercise, skim a research paper's introduction and conclusion. Summarize the purpose in 2 sentences. Scan an equipment manual to identify safety precautions and maximum load capacity. 4.2 Understanding manuals and specifications. Structure of technical manuals. 1. Safety guidelines, warnings and compliance standards, e.g., ISO, ANSI. 2. Installation steps, sequential, numbered instructions. 3. Troubleshooting, flowcharts or tables for diagnosing issues. 4. Technical specs, numerical data, e.g., torque values, tolerances. Key strategies, decode symbols/abbreviations, refer to the glossary, e.g., RPM equals revolutions per minute. Visual aids, use diagrams, schematics, or exploded views to clarify text. Case study, misinterpreting maximum input, 240 VAC as DC in a power supply manual caused equipment failure. Exercise, analyze a snippet from a CNC machine manual. Identify key warnings, installation steps, and operational limits. 4.3 Analyzing research papers and journals. Anatomy of a research paper. 1. Abstract, summary of objectives, methods, and findings. 2. Methodology, experimental setup, tools, and procedures. 3. Results, data, tables, graphs, and statistical analysis, e.g., p-values. 4. Conclusion, implications and future work. Critical evaluation tips, assess validity, check sample size, control groups, and peer review status. Identify bias, note funding sources or overly subjective language. Focus on figures, graphs often convey key findings faster than text. Exercise, review a peer-reviewed paper on renewable energy. Extract the hypothesis, methodology, and one key graph. Critique the study's limitations. Chapter takeaways, skim/scan, save time by prioritizing sections and extracting essentials. Manual/specs, navigate structured documents with attention to safety, visuals, and technical data. Research papers, critically analyze methodology and results to assess credibility. Next chapter, Chapter 5, Writing technical documents teaches structuring reports, proposals, and manuals. Tools and tips, use PDF search, Ctrl+F, to scan digital documents. Apps like Mendeley or Zotero help organize research papers. Always cross-reference unclear terms with glossaries. Appendix A. Real-world example, an engineer schemed a 50-page feasibility study, focused on the conclusions cost-benefit analysis, and recommended a solar panel project saving 10+ hours of reading. This chapter equips engineers to efficiently navigate technical texts, ensuring accuracy and informed decision-making. Chapter 5, Writing technical documents. 5.1 Structuring engineering reports. Purpose, communicate findings, analyses, and recommendations clearly and professionally. Key sections, 1. Title page, project title, author, date, institution/company. 2. Abstract, concise summary, 150-250 words, of objectives, methods, results, and conclusions. 3. Table of contents, navigational aid with section headings and page numbers. 4. Introduction, context, problem statement, objectives, and scope. 5. Methodology, detailed procedures, tools, and materials used. 6. Results, data, tables, graphs, and observations, avoid interpretation. 7. Discussion, analysis of results, implications, and limitations. 8. Conclusion, key takeaways and recommendations. 9. References, citations adhering to APA, IEEE, or other standards. 10. Appendices, supplementary material, raw data, code snippets. Tips, use headings/subheadings for readability. Define acronyms, e.g., FEM, finite element method. Include visual aids, e.g., Figure 1, stress distribution in the beam. Checklist, abstract summarizes key points. Methodology is reproducible. Results are presented objectively. Discussion links findings to objectives. 5.2 Crafting proposals and project plans. Proposals, persuasive documents, structure, executive summary, problem statement, objectives, technical approach, timeline and budget, team qualifications, key tips, align with stakeholder needs, e.g., cost savings, innovation, include risk assessment/SWOT analysis. Project plans, operational documents, components, scope statement, work breakdown structure, WBS, Gantt chart/timeline, resource allocation, risk management plan, methodologies, waterfall, sequential phases, design build test. Agile, iterative sprints with stakeholder feedback. Tools, Microsoft Project, Trello, Asana. Example proposal hook. This proposal outlines a cost-effective solar-powered irrigation system to reduce water waste by 40% in rural regions. 5.3 Technical manuals and user guides. Audience-specific writing, user guides, end users, simple language, step-by-step instructions, e.g., press the power button, safety warnings, FAQs, troubleshooting basics. Technical manuals, technicians, detailed schematics, diagnostics, and repair protocols. Compliance with standards, e.g., ISO 9001. Structure, 1. Safety precautions. 2. Installation instructions. 3. Operating procedures. 4. Maintenance guidelines. 5. Troubleshooting flowcharts. Design tips, use numbered lists for sequential steps. Include annotated diagrams, e.g., Component A, voltage regulator. Test with target users for clarity. Example, Step 3, secure the bracket using 4M6 bolts, torque, 10 Nm, dot. 5.4 Standard phrases for clarity and professionalism. Common phrases, instructions, ensure the device is grounded before activation. Recommendations, it is advisable to calibrate sensors weekly. Warnings, do not exceed 250V input to prevent circuit damage. Conclusions, the data suggests a 15% efficiency improvement. Avoid ambiguity. Weak, the system might fail under load. Strong, the system fails at loads 50 knots, see Table 2. Style tips, use active voice for directives, install the software versus the software should be installed, maintain consistent terminology, e.g., module versus component. Pitfalls to avoid, overusing passive voice. Jargon without definitions. Unsupported claims, e.g., best in class without data. Practical exercises. 1. Report writing, draft an abstract for a structural analysis report. 2. Proposal exercise, outline a project plan for a bridge retrofit. 3. User guide, rewrite a vague instruction, adjust settings as needed. Tools and resources, templates, IEEE report templates, OSHA safety guidelines. Software, Grammarly, proofreading, LaTeX, typesetting. Key takeaway, effective technical writing combines precision, structure, and audience awareness to ensure clarity and professionalism. Chapter 6, Professional Email Communication. 6.1 Formal versus informal tone. When to use formal tone, communicating with clients, stakeholders, or senior management. Initial outreach or unfamiliar contacts. Delivering sensitive information, e.g., delays, budget issues. When informal tone is acceptable, daily communication with close colleagues. Quick internal updates or follow UPS. Examples, formal informal Dear Dr. Smith, I am writing to request your feedback on the attached schematic *. Hi Alex, could you review the schematic by EOD? Thanks. Please find the revised project timeline attached for your review. Here's the updated timeline, let me know your thoughts. Key tips, greetings/sign-offs, formal, dear name/best regards, informal, hi name/cheers, avoid slang, emojis, or overly casual language in formal contexts. Adjust tone based on relationship and context, but always prioritize clarity. 6.2 Writing clear requests and responses. Structuring requests: 1 subject line, specific and actionable, e.g., action required, approval for prototype, budget by Friday. 2 Opening, state purpose clearly, I'm writing to request. 3 Context, briefly explain why the request is needed. To meet the Q3 deadline, we need. 4 Deadline, specify timing, kindly respond by COB Thursday. 5 Close, express appreciation, thank you for your prompt attention to this matter. Example request: subject, urgent, sensor calibration data needed by 5 p.m. today. Dear team, I'm writing to request the calibration data for sensor X 2023. This is critical for finalizing the test report due to the client tomorrow. Please share the files via email by 5 p.m. today. Thank you for your urgent support. Best, Jane. Effective responses: acknowledge receipt, thank you for your email. Answer directly: yes, we can deliver the components by June 10. Provide next steps or deadlines: I'll follow up with the test results by Friday. Avoid vague language: I'll get back to you soon, I'll share the report by 3 p.m. Wednesday. Over-explaining: keep responses concise. 6.3 Managing project updates and deadlines. Progress updates. Structure: 1 Summary of completed tasks. 2 Current status/blockers. 3 Next steps. 4 Reaffirm deadlines. Example: subject, Project Alpha update May 30th. Hi team, 1 Completed, PCB design finalized, prototype assembly 80% done. 2 Blockers, awaiting capacitor shipment, delayed by 2 days. 3 Next steps, begin testing upon delivery, ETA June 2nd. 4 Deadline, on track for June 15th demo. Best, Carlos handling missed deadlines. Do, inform stakeholders immediately. Explain briefly: due to supplier delays, phase 1 will shift by 3 days. Propose solutions: we'll add weekend shifts to minimize impact. Don't make excuses or blame others. Follow-up tips: use tools like shared calendars, Google Calendar, or project software, Asana, for visibility. Send polite reminders 24-48 hours before deadlines. Friendly reminder: please submit your feedback by tomorrow. Chapter takeaways: tone, match formality to audience and context. Clarity, direct requests/responses save time and reduce confusion. Deadlines, proactive updates build trust, always communicate delays early. Exercise: 1 Convert an informal email to formal tone. 2 Draft a response to, can you check the wiring diagram? Assume you need 2 more days. 3 Write a deadline extension email to a client due to a supplier delay. Tools: Grammarly, tone adjustments, Boomerang, email scheduling. This chapter equips engineers to communicate efficiently, ensuring professionalism and accountability in all email interactions. Chapter 7, Delivering Effective Presentations. Mastering technical communication through structured content, engaging delivery, and confident Q&A handling. 7.1 Structuring technical slides. 1. Introduction, purpose, set context, state objectives, and hook the audience. Example slide, title: Optimizing solar panel efficiency in urban environments. Problem statement: current solar arrays underperform in shaded areas. Objective: develop a dynamic shading mitigation system. 2 Methods, key elements, tools, processes, experiments. Visual aids, flowcharts, diagrams, or timelines. Example: used MATLAB simulations to model shading effects. Field-tested prototypes in 3 urban locations. 3 Results, data presentation, graphs, tables, use annotations. Example: bar chart comparing efficiency gains, pre/post mitigation. Key takeaway: 35% efficiency improvement in shaded conditions. For conclusion, summarize, key findings and implications. Future work, next phase, scalability testing for commercial deployment. Pro tips, limit text to 6 lines/slide, use bullet points. Avoid jargon, define acronyms, e.g., PV for photovoltaic. 7.2 Engaging your audience, visuals and delivery. Visual design, tools, PowerPoint, Canva, LaTeX Beamer. Best practices, color, high contrast, e.g., dark text on light background. Fonts, sans serif, Arial, Calibri, 24+ PT for body text. Animations, use sparingly, e.g., fade-ins for key points. Delivery techniques, body language, stand tall, use open gestures, and move purposefully. Eye contact, scan sections of the room, not just one person. Voice modulation, pause before key points, vary pitch to emphasize ideas. Practice, rehearse with a timer, record yourself for feedback. Audience engagement, interactive elements, polls, how many here have encountered shading issues? Rhetorical questions, what if we could reclaim 35% efficiency? Storytelling, case study, a school in Tokyo reduced energy costs by 20% using our system. Accessibility tips, provide alt text for images, avoid red-green color schemes. 7.3 Handling Q&A sessions with confidence. Preparation, anticipate questions, list 5-10 likely queries, e.g., how scalable is the solution? Prepare backup slides for detailed data, e.g., cost-benefit analysis. During Q&A 1. Listen fully, let the questioner finish, nod to acknowledge. 2. Responding, known answer, great question. Our simulations showed, unknown, I'll need to verify that. Let me follow up post-session. 3. Hostile questions, stay calm, I appreciate your concern. Our data suggests, redirect, let's discuss this offline to dive deeper. Body language, maintain eye contact, avoid crossing arms. Cultural sensitivity, in some cultures, defer to senior attendees first. Post Q&A, thank the audience, share contact info for follow UPS. Key takeaways. 1. Structure, introduction, methods, results, conclusion. 2. Visuals, simplify data, prioritize readability. 3. Delivery, practice, modulate voice, and engage interactively. 4. Q&A, prepare thoroughly, stay composed and courteous. Exercise, draft a 5-slide presentation on a past project. Practice delivering it to a peer, then simulate a Q&A. Tools, Grammarly, Clarity, OBS Studio, recording rehearsals. This chapter transforms technical content into compelling narratives, ensuring your expertise shines through every presentation. Chapter 8, Participating in Meetings and Discussions. Strategies for productive meetings, from preparation to execution and follow-through. 8.1 Agenda setting and active listening. Effective agenda setting. 1. Define objectives, clearly state the meeting's purpose, e.g., finalize prototype design. 2. Prioritize topics, rank items by urgency, e.g., 1. Budget approval, 2. Timeline revision. 3. Assign time limits, allocate slots per topic to avoid overruns, e.g., risk assessment, 15 minutes. 4. Pre-circulate materials, share reports/data beforehand to enable informed discussions. Example agenda, topic owner time outcome budget review finance team 10 minutes approved adjustments prototype feedback engineering 20 minutes design revisions finalized active listening techniques, focus, avoid multitasking, maintain eye contact. Clarify, to confirm, you're suggesting we prioritize Module A. Summarize, so the key concern is supply chain delays. Let's explore solutions. Pitfalls to avoid, dominating the conversation. Ignoring nonverbal cues, e.g., crossed arms signaling disagreement. 8.2 Expressing opinions and negotiating solutions. Assertive communication, phrasing opinions, use evidence. The stress test data suggests we need thicker materials. Stay respectful, I recommend X, but I'm open to alternatives. Disagreeing diplomatically, I see your point, but have we considered Y? Negotiation strategies, 1 BATNA, best alternative. Know your fallback, e.g., if we can't agree, we'll proceed with vendor B. 2 Interest-based, focus on shared goals, e.g., we both want the project on time, how can we adjust scope? 3 Compromise, we'll extend the deadline by a week if you approve overtime costs. Case study, a team resolved a design conflict by agreeing to test both materials and using performance data to decide. Tools, RACI matrix to clarify roles, responsible, accountable, consulted, informed. Conflict resolution frameworks like Thomas Gilman. 8.3 Documenting action items and follow UPS. Effective meeting minutes, key sections, 1 Decisions made. 2 Action items, with owners and deadlines. 3 Open questions for follow-up. Example, action, procurement to finalize vendor contracts by Friday, owner, Jane. Follow-up. Best practices, 1 Send minutes promptly, within 24 hours. 2 Track progress, use tools like Asana or Microsoft Planner. 3 Accountability check, start the next meeting with a status update. Common pitfalls, vague tasks, improve efficiency. Optimize code by reducing API calls by 20% by 7/30. Missing deadlines due to unclear ownership. Template for action items, task owner deadline status revise CAD drawings. Alex July 25th in progress. Test thermal sensors Priya July 30th not started. Chapter takeaways. 1. Agendas keep meetings focused, active listening builds collaboration. 2. Assertive communication and negotiation resolve conflicts while preserving relationships. 3. Clear documentation ensures accountability and progress. Exercises, 1. Draft an agenda for a project kickoff meeting. 2. Role-play a disagreement over resource allocation and negotiate a solution. 3. Convert vague action items into SMART goals, specific, measurable, achievable, relevant, time-bound. Tools, Trello/Asana for task tracking. Otter.ai for automated meeting notes. This chapter equips engineers to lead and contribute effectively in meetings, turning discussions into actionable results. Chapter 9, Listening and Pronunciation * Mastering comprehension and clarity in technical communication through active listening and precise pronunciation. 9.1 Understanding diverse English accents. Common accents in global engineering, American, flat intonation, rhotic R, e.g., engineer pronounced engineer. British, non-rhotic R, e.g., water as water, varied regional dialects, e.g., Scottish, Cockney. Indian, syllable stress differences, e.g., ma-nager versus manager, rolled R, Australian, vowel shifts, e.g., data as data. Strategies for comprehension, 1. Focus on context, use technical terms as anchors, e.g., torque, algorithm. 2. Practice with authentic materials, TED Talks by international engineers. YouTube channels like Practical Engineering, diverse presenters. 3. Ask for clarification, could you repeat the tolerance value? Did you mean 5 mm or 5 cm? Exercise, listen to a technical briefing by a non-native speaker, e.g., Indian accent, and transcribe key specs. 9.2 Technical vocabulary pronunciation practice. Commonly mispronounced engineering terms, term correct pronunciation. Mispronunciation gauge /ed/ gaoi, gaoi fatigue /ft/ fatigue fat ihgu algorithm /ael.rm /algut thumb algorithm resistor/rzs.tr/risistor, resistor practice techniques, phonetic drills, use IPA. International Phonetic Alphabet, guides. Shadowing, repeat after audio clips of technical terms, e.g., NASA podcasts. Tongue twisters, 6 sleek circuits systematically solved sensor signals. Tools, Forvo, crowdsourced pronunciation database. Google Translate, audio playback for tricky words. Case study, an engineer mispronounced welding as wielding during a safety briefing, leading to confusion. Post-training, the team adopted weekly pronunciation drills. 9.3 Note-taking during lectures or briefings. Structured note-taking methods, 1 Cornell method, cues, key terms, e.g., thermal expansion. Notes, details, e.g., asterisk coefficient, 12 times 10/degree C for steel. Summary, main takeaway, e.g., material choice critical for high-temp apps. 2 symbols/abbreviations, delta equals change, equals risk, W/equals width, e.g., equals for example. 3 sketch notes, combine diagrams and text, e.g., stress-strain curve and annotations. Active listening tips, identify keywords, listen for numbers, units, and imperatives, e.g., must, avoid. Filter redundancies, ignore filler phrases, e.g., as I mentioned earlier. Example notes from a lecture on robotics, topic, actuators in robotic arms, types, pneumatic, air, hydraulic, fluid, electric, motors. Pros/cons, electric, plus precise, less torque. Hydraulic, plus high force, leak risk. Application, electric for assembly lines, hydraulic for heavy lifting. Exercise, listen to a 10-minute lecture on renewable energy systems. Use the Cornell method to capture key specs, e.g., efficiency rates, materials. Chapter takeaways, accent adaptation, context and practice bridge comprehension gaps. Pronunciation precision, avoid errors that lead to costly misunderstandings. Effective notes, structured methods ensure critical data isn't lost. Tools and resources, apps, Elsa Speak, pronunciation, Evernote, note organization. Websites, BBC Learning English, Accent Training, Engineering.com, Technical Lectures. Next chapter, Chapter 10, Working in Global Teams explores virtual collaboration and cultural sensitivity. Final exercise, record yourself explaining a technical process, e.g., how a circuit breaker works, and compare your pronunciation to a native speaker's demo. This chapter ensures engineers can listen, speak, and document with clarity essential skills for global collaboration and precision-driven fields. Chapter 10, Working in Global Teams Strategies for Seamless Collaboration Across Borders, Time Zones, and Cultures. 10.1 Virtual Communication Tools, Slack, Zoom, Teams, Tool Comparison, Tool Best for Key Features Slack Instant Messaging, File Sharing Channels, Integrations, Google Drive, Trello, Threaded Conversations. Zoom Video Conferencing Breakout Rooms, Recording, Virtual Backgrounds. Teams Integrated Collaboration Document Collaboration, Task Tracking, SharePoint Sync. Best Practices, Slack, Organize channels by project, number project alpha, or topic, number design reviews. Use status updates, e.g., in a meeting until 3 p.m. GMT. Zoom, set agendas and share them pre-meeting. Use polls/whiteboards for engagement. Teams, leverage Planner for task assignments and deadlines. Case study, a German-Japanese team used Slack for daily check-ins and Zoom for weekly sprints, reducing email overload by 40%. Exercise, create a Slack channel for a mock project and draft a pinned post outlining communication norms. 10.2 Clarifying roles and responsibilities RACI matrix example, task responsible accountable consulted informed budget approval finance team project manager stakeholders all members prototype testing QA engineers lead engineer design team clients strategies, kickoff meetings, align roles using visual aids, e.g., RACI charts. Documentation, share role descriptions in a central hub, e.g., Confluence. Regular check-ins, address overlaps/gaps in weekly syncs. Pitfalls to avoid, vague titles like support the team review code commits daily. Exercise, draft a RACI matrix for a software rollout involving developers, testers, and UX designers. 10.3 Resolving misunderstandings in multinational projects common causes, cultural misalignment, direct versus indirect communication styles. Language barriers, idioms, e.g., think outside the box, confusing non-native speakers. Time zone delays, asynchronous replies leading to fragmented discussions. Resolution framework, 1. Acknowledge, I notice there's confusion about the deadline. Let's clarify. 2. Clarify, restate the issue using simple language. 3. Collaborate, involve neutral mediators if needed. 4. Document, update plans/agreements in shared tools. Case study, AU.S Indian team resolved a deadline conflict by switching from email to Zoom for real-time discussion. Using a shared Gantt chart to visualize dependencies. Agreeing on daily Slack updates during overlapping hours. Cultural sensitivity tips, research norms, e.g., hierarchy in Korean teams versus flat structures in Swedish teams. Use tools like Hofstede Insights to compare work cultures. Exercise, role-play a scenario where a supplier misinterprets a technical spec due to language issues. Practice restating requirements clearly. Key takeaways 1. Tools, match Slack/Zoom/Teams to your team's workflow. 2. Roles, use RACI matrices to prevent overlaps and ensure accountability. 3. Conflict resolution, prioritize clarity, cultural awareness, and documentation. Actionable checklist, schedule a tool training session for remote teams. Draft a RACI matrix for current projects. Add cultural sensitivity resources to the team's knowledge base. Next chapter, Chapter 11, Cultural Awareness in Engineering dives into workplace etiquette and inclusive communication. This chapter equips teams to navigate global collaboration with precision, fostering trust and efficiency in multicultural environments. Chapter 11, Cultural Awareness in Engineering fostering respect, collaboration, and inclusivity in global engineering teams. 11.1 Workplace etiquette across cultures key considerations, 1. Hierarchy and formality, East Asia, e.g., Japan, South Korea address seniors by title, e.g., Manager Lee, avoid direct disagreement in public, Nordic countries, e.g., Sweden flat hierarchies, first names are common, even with superiors. 2. Punctuality, Germany/Switzerland, strict adherence to timelines, delays signal disrespect. Middle East/India, flexible timelines, INSH a la culture, confirm meetings day of. 3. Gift giving, China, exchange business gifts at first meetings, avoid clocks symbolize death. USA, gifts may be seen as bribes, opt for team lunches instead. 4. Meeting dynamics, Brazil, relationship building through small talk. Israel, debates are encouraged, interruptions show engagement. Case study, a German engineer misinterpreted a Brazilian team's informal brainstorming as disorganization. After adapting to relationship-focused meetings, collaboration improved. Actionable tips, research cultural norms using tools like Hofstede Insights. Clarify expectations upfront, e.g., should we schedule follow UPS weekly or bi-weekly? 11.2 Bridging communication styles, direct versus indirect, direct communication, e.g., US, Germany, Israel, traits, blunt feedback, explicit requests, example, this design won't work. Redo it by Friday. Indirect communication, e.g., Japan, Thailand, UK, traits, implied meaning, softened critiques, example, perhaps we could explore alternative designs for better alignment. Strategies for bridging styles, 1. Active listening, paraphrase to confirm understanding, to clarify, you're suggesting. 2. Adapt feedback, direct indirect, add qualifiers, could we consider. Indirect direct, use data to soften bluntness, the stress test shows. 3. Nonverbal cues, note hesitations, e.g., silence in Japanese team signals disagreement. Exercise, rewrite a direct email request, fix the code now, for an indirect culture recipient. 11.3 Ethical and inclusive language best practices, 1. Gender neutrality, use they instead of he/she, avoid guys, e.g., team, please review. 2. Accessibility, avoid idioms, think outside the box, propose innovative solutions. Use plain language for non-native speakers. 3. Cultural sensitivity, respect religious/cultural holidays, e.g., avoid deadlines during Ramadan. Avoid assumptions, e.g., not all engineers celebrate Christmas. Pitfalls to avoid, microaggressions, your English is so good. Asterisk, implies surprise. Exclusionary jargon, this is a no-brainer, alienates non-native speakers. Case study, a UK team's use of cricket metaphors, hit a 6, confused Indian colleagues. Switching to sports-neutral terms improved clarity. Checklist for inclusive docs, use alt text for images. Define acronyms, e.g., FIA, finite element analysis. Avoid culturally specific humor. Chapter takeaways. 1. Etiquette, adapt to hierarchy, time, and gift-giving norms to build trust. 2. Communication, balance directness and tact to bridge cultural gaps. 3. Inclusivity, prioritize neutral, accessible language to empower all team members. Reflection exercise, recall a past project conflict. How might cultural differences have contributed? What would you do differently now? Next chapter, Chapter 12, Real-world case studies applies these principles to global engineering scenarios. This chapter equips engineers to navigate cultural nuances with empathy, ensuring projects thrive in diverse, interconnected environments. Chapter 12, Real-world case studies applying technical English skills to practical engineering scenarios. 12.1 Writing a project report, step-by-step example scenario, you're tasked with documenting the development of a solar-powered irrigation system for a rural community. Step-by-step guide, 1 title page, project title, design and implementation of a solar-powered drip irrigation system in rural Kenya. Authors, include names, affiliations, and date. 2 Abstract, 150 words, objective, reduce water waste by 40% using renewable energy. Methods, field tests, MATLAB simulations, stakeholder surveys. Results, 35% water savings, 20% cost reduction. 3 Introduction, problem, droughts and inefficient water use in sub-Saharan Africa. Solution, solar-powered drip irrigation with IoT soil sensors. 4 Methodology, tools, PVSYST, solar modeling, AutoCAD, system design. Field tests, conducted in 3 villages over 6 months. 5 Results, data, table comparing water usage pre/post installation. Challenges, sensor calibration issues in high humidity. 6 Conclusion, impact, scalable model for similar regions. Next steps, partner with NGOs for wider deployment. Case study template, markdown number, project title number, abstract summary number 1. Introduction, context and objectives number 2. Methodology, tools/processes number 3. Results, data and visuals number 4. Conclusion. Key takeaways. Exercise: draft a report outline for a bridge retrofit project, including methodology and expected results. 12.2 Simulated client meeting, role-play exercise scenario, present a smart traffic management system to a municipal client. Roles: engineer, explain technical specs, costs, and timelines. Client, raise concerns about budget and scalability. Moderator, ensure agenda adherence and document decisions. Sample agenda: 1. Introduction, 5 mins project scope and goals. 2. Technical overview, 10 mins sensor networks, AI algorithms. 3. Budget and timeline, 10 mins breakdown of $1.2 million over 18 months. 4. Q&A, 15 mins address client concerns, e.g., cybersecurity risks. 5. Next steps, 5 mins sign off on action items. Role-play dialogue: client, how will this system handle peak traffic during festivals? Engineer, our AI dynamically adjusts signal timings using real-time data. During Diwali trials, congestion dropped by 25%. Tips for success: use visuals, e.g., traffic flow charts. Practice active listening and rephrase client concerns. Exercise: simulate a meeting where the client requests a 20% budget cut. Negotiate scope adjustments, e.g., phased rollout. 12.3 Peer review of technical documentation. Objective: improve clarity, accuracy, and professionalism in a peer's document. Review checklist: criteria. Questions to ask: clarity, are terms like torque or API defined? Accuracy: do calculations match the data provided? Structure: is the report logically organized? Visuals: do graphs have labels and legends? Grammar: passive voice used appropriately? Sample document excerpt: original, the system worked good but needs more better sensors. Feedback: the system performed adequately but requires higher accuracy sensors, e.g., plus or minus 0.1% tolerance. Best practices: use track changes in Word or Google Docs. Balance critique with positive feedback. * Your methodology section is thorough, but the abstract needs a clearer objective. Exercise: 1. Swap reports with a peer. 2. Review using the checklist. 3. Provide actionable feedback, e.g., add units to Table 3. Key takeaways. 1. Reports: structure with clarity, data, and actionable insights. 2. Client meetings: prepare agendas, anticipate concerns, and negotiate solutions. 3. Peer reviews: foster improvement through constructive, detail-oriented feedback. Tools and templates: report template, download link, meeting agenda builder, Microsoft Teams planner, peer review rubric, Google Sheets template. Next chapter, Chapter 13, Resources for Continuous Improvement, shares tools for lifelong learning in technical English. This chapter bridges theory and practice, empowering engineers to communicate technical ideas effectively in real-world contexts. Chapter 13, Resources for Continuous Improvement, empowering engineers to refine their technical English skills through curated tools and networks. 13.1 Recommended books, websites, and podcasts. Books: Technical Writing, The IEEE Guide to Writing in the Engineering and Technical Fields. Hertz and Roberts aligns with industry standards. English for Engineering, A Professional Guide, Glendening and Holmstrom. Discipline-specific vocabulary and exercises. Grammar and Style, The Elements of Technical Writing, Pearsall simplifies complex grammar for technical contexts. Technical Communication Today, Johnson Sheehan blends writing strategies with digital tools. Websites: Coursera/edX, courses like Technical English for Engineers, University of London, or Effective Communication for Technical Professionals, MIT. Engineering.com, articles, forums, and webinars on industry trends. Grammarly, enhances grammar and tone in technical documents. Podcasts: The Engineering Career Coach, discusses communication skills in engineering roles. Tech Stuff explores tech innovations with clear, conversational English. English for Engineers, Spotify focuses on technical vocabulary and interview prep. Case study, an Indian software engineer improved their technical writing by combining Grammarly with the IEEE guide, leading to a 50% reduction in document revisions. 13.2 Engineering Journals and Professional Networks Journals, IEEE Explore, peer-reviewed papers in electrical, mechanical, and software engineering. ASME Digital Collection, Mechanical Engineering Research with Standardized Terminology. Nature Engineering, Cross-Disciplinary Innovations and High-Impact Studies. Networks, LinkedIn Groups, Global Engineering Network and Women in Engineering. Professional Organizations, IEEE, offers webinars, conferences, and mentorship programs. Engineers Without Borders, combines technical collaboration with language practice. Exercise, join an IEEE webinar, summarize key takeaways in English, and share them on LinkedIn. 13.3 Language Learning Apps for Technical Vocabulary Specialized Apps, Quizit, create flashcards for terms like finite element analysis or hydraulic conductivity. Memrise, courses like Engineering English Basics. Speak Engineering, app with audio pronunciations and contextual examples. General apps, tailored use, Anki, custom decks for memorizing ISO standards or CAD commands. Duolingo English Test, practice technical reading/listening sections. Online tools, Oxford English Dictionary, technical term definitions and etymology. TechTerms.com, simplified explanations of software/hardware jargon. Tip, peer app learning with real-world application, e.g., label lab equipment in English. Key takeaways 1. Books and courses, build foundational skills in technical writing and grammar. 2. Journals and networks, stay updated on trends while immersing in professional English. 3. Apps and tools, customize learning to master discipline-specific vocabulary. Action plan, 1. Dedicate 30 minutes daily to a resource, e.g., podcast and app. 2. Join one professional network and engage in quarterly events. 3. Partner with a peer for accountability, e.g., weekly vocabulary quizzes. Final note, lifelong learning in technical English ensures competitiveness in global engineering landscapes. Stay curious, stay connected. This chapter provides a roadmap for engineers to refine their communication skills, bridging technical expertise with linguistic fluency. Appendices Appendix A, Glossary of Engineering Terms, definitions of key terms across engineering disciplines for quick reference. Term definition example/usage --torque rotational force applied to an object, unit, Nm. The motor delivers 150 Nm of torque at 3000 rpm. Ohm's law \V equals IR \voltage equals current multiplied by resistance. Using Ohm's law, calculate the resistor value. Finite element analysis, FEA, numerical method for solving complex structural problems. FEA predicted stress concentrations in the beam. API application programming interface, rules for software interaction. Integrate the payment gateway via REST API. Alphabetical order, cross-referenced by discipline, mechanical, electrical, software, etc. Appendix B, sample documents, templates and annotated examples for real-world engineering communication. 1. Technical report, title page, project title, authors, date. Abstract, summary of objectives, methods, results. Body, sections marked with comments, e.g., use passive voice here for objectivity. Download link, sample PDF with annotations. 2. Professional email, formal request, subject, request for budget approval solar panel project. Dear Dr. Lee, I am writing to request approval for the additional $15,000 budget to address supply chain delays. Casual update, subject, prototype testing complete, next steps. Hi team, great news. The prototype passed all stress tests. Let's meet Friday to review. 3. Presentation slide deck, slide 1, title and visual, e.g., infographic of project phases. Slide 2, problem statement with data, e.g., 40% energy loss in current system. Slide 3, methodology flowchart. Appendix C, common abbreviations and symbols. Quick reference for frequently used shorthand in engineering. Abbreviation meaning, symbol meaning, CAD computer aided design, omega ohms, electrical resistance, IoT Internet of Things, sigma stress, MPa, via finite element analysis, lambda wavelength, m, BOM bill of materials, delta change, e.g., delta T equals 10 degrees Celsius, organized by discipline, mechanical, electrical, civil, software. Appendix D, answer key for exercises, model answers and explanations for chapter exercises. Chapter 3, Grammar, Exercise 1, Convert to passive voice. Original, the team tested the prototype. Answer, the prototype was tested by the team. Chapter 7, Presentations, Exercise 2, Draft a slide on renewable energy. Answer, example, title, wind turbine efficiency, problem, 20% downtime due to low wind. Solution, hybrid solar wind system. Result, 35% uptime improvement. Chapter 12, Case Studies, Role-play feedback, effective negotiation, phased rollout, maintained client trust while cutting costs. Formatting notes, navigation, hyperlink table of contents for digital editions. Consistency, terms align with glossary, symbols match industry standards, ISO/IEC. Accessibility, alt text for visuals in samples, plain language explanations. These appendices provide actionable resources to reinforce learning, ensuring readers can confidently apply technical English in global engineering contexts.